Drug poisonings cause thousands of deaths worldwide, and a key factor can prevent this: time. Fast and accurate detection of drug molecules can mean the difference between life and death. Current diagnostics are relatively slow for molecules that are toxic in very low quantities, and it might take too long for the patient.
Currently, there are no point-of-care methods like this. Usually, a blood sample is drawn and it's sent to liquid chromatography. So at the best case scenario, you might have results in 2 hours, which might already be too late.
In an ambitious FinnCERES project called LA FAST, a multidisciplinary team is working on a novel solution to create fast, highly sensitive, and highly selective small molecule sensors. The key ingredient in the technology is to combine carbon nanoparticles with bio-based nanocellulose.
Then we use sonication to make them properly mixed, and it will be a very stable dispersion for many years usually.
The carbon nanomaterials are the active elements in sensing. So typically we use electrochemistry, which is based on that we change the voltage and then we measure the current. So the carbon nanotubes provide the functionality, and then the nanocellulose is actually dispersing these very, very small entities very effectively, so we get a huge area. If we get a huge area, we get also large currents, and then we can detect very small amounts of molecules.
And when we have this dispersion of these 2 materials, we can later on cast different kind of structures from this mixture.
Not only do the 2 materials together offer high selectivity, but also high sensitivity, which tackles a big challenge in the field.
Medical diagnostics, I think the biggest problem is when you want to be able to detect drugs that are present in very low concentrations. Not only does our material need to be very sensitive to the drug that we want to detect, but it should be selective to only the drug and not everything else that is usually present in a human sample.
The key factor for higher sensitivity comes from the natural properties of nanocellulose.
It's very hygroscopic, so it absorbs a lot of moisture. So there is a possibility to, for example, enhance the influx so that we get more analyte to our structures. Because carbon nanomaterials are typically hydrophobic, so they don't like water. So it's not always easy to get the solvent to penetrate into our structures. And now when we put nanocellulose there, it attracts water there. And then we get more and more analyte to come with that influx of solvent.
The combination of these materials shows very promising detection results compared to current commercial solutions, achieving detection in the nanomolar range.
A commercial standard multi-wall carbon nanotube modified electrode, it's unable to detect, for example, 1 micromolar of dopamine or less than that. Interference solution or human plasma, which contains other molecules like uric acid and ascorbic acid. But simply with our nanocellulose and carbon nanotube mixture, we can push the detection limit down to a few hundred nanomolars. So it is definitely going in the right direction.
The scientists are also looking beyond current medical applications to explore the full potential of this technology.
It's very useful also in environmental applications, in wastewater treatment, and also gas sensing, for example. When you exhale, there are different kind of molecules that can indicate certain diseases. And these are quite often present at very low concentrations. And then the latest one is to utilize these to detect antibiotic residues from wastewaters. So there we have to go also to very, very low amounts of substance. And these are aiming so that we could detect and then also enrich and then degrade these antibiotic residues from wastewater so they don't end up into the ocean.
We are also working on a battery development project where we also need this hybrid material that is carbonized, and so that we would be able to build batteries without lithium.
The research has raised many new questions, and its full potential is yet to be discovered.
So I think it's good to go for the people who have the questions and not the answers. Because we typically, when we learn more, we learn what are the right questions that need to be expressed.